All right, 3.12 notes here. 3.12. So the main concept here is horizontal shifts. Horizontal shifts. This is another video like the last one that you may find yourself needing to pause frequently because there's a lot of drawing. And I'm going to go on and continue explaining, but please use the concept of pausing to help you catch up and stay up with me and draw your graphs because that is very important. All right, so on our first box here, we've got a set of x values and then a function already drawn for us, f of x equals x squared. So we got to fill in our chart here with the values for x squared. So we just take each x value and square it. And we see some nice symmetry in our chart. Everything's centered around 0. And when we square the negative values, we get the same thing as when we square the positive values. Now also, we should go ahead and plot these points on our graph. So -3, 9, and -3 input value with 9 as an output value. -2, 4. -2 as an input value with 4 as an output value. Okay, because these points are going to help us move on to the other functions. The next column in our chart is a new function, g of x, and it's x plus 1 quantity squared. So if I want to fill in the stuff in this chart, for this first box here, what is my x value? My x value is -3, so I plug that in. -3 plus 1, -2, and then square it to get 4. And okay, so I plot this input and output for g of x on my graph. The input was -3, so I go over to -3, and the output here was 4, so I go up to 4. Now the next one here, input of -2, I plug it in, -2 plus 1 becomes -1, and then square it, and I get 1. And I continue on in this fashion, plugging in my x values into g of x to get new output values for this new function. Now, one thing to note here is think about what happened to the x value when we plugged it in. When we plug into f of x, originally we just square the x value right away. So for instance, like 0. 0, we plugged it in and we squared it. Now what we're doing is we're plugging it in, we're adding 1 to it. So basically we're looking at the next column. So when I plug in 0, I'm really taking 1 and squaring it. When I plug in 1, I'm going to get 2 and then square it. When I plug in 2 into g of x, I'm going to get 3 and then square it. So that should help us to see kind of this pattern here. So we have all of our points plotted. Wow, that was backwards. And we draw our graph of g of x. And then what we notice here, when we compare the points on our original function, f of x, to the points on our new function, g of x, is that everything shifted to the left by 1 unit. When I did a +1 in the parentheses there with the x, everything shifted to the left 1 unit. Okay, let's look at that next column. H of x equals quantity x minus 2 squared. So I plug in my x value of -3. First I subtract 2 to get -5, and then I square it to get 25. And I plot my points. Well, this one right here, -3, 25, doesn't fit on there. Okay, the next one I plug in -2, -2 is -4, and then square it to get 16. I continue on in the same fashion here, plugging in my original x values, always using the same x values, but plugging them into this new function and plotting the resulting points. So for instance, this last point, I plugged in 3, I got an output of 1. So over here, I go to 3 and then up to 1, 3, 1. Now we graph that function, connect it, and what we realize when we compare these points to our original points is that every single point has been shifted to the right by 2 units. So when I have -2, I shift everything to the right by 2 units. Okay, so this is our rule here. The graph of y equals f of x plus or minus h, where the plus or minus h is in the parentheses with the x. It's in there with the x. You might need to add the plus sign in there. I don't believe that made it into your notes. Is shifted in what ways? Well, if it's x minus h, we go h units to the right. So if we subtract 3, we go 3 units to the right. If we subtract 10, we go 10 units to the right. It's just like the x minus 2 squared went 2 units to the right. Now it's h units to the left if we add h. So if it's x plus 3, we go 3 units to the left. If it's x plus 1, we go 1 unit to the left, just like when we had x plus 1 there. And the graph, something to write down that might help you to remember this is that the graph moves the opposite of what you would expect. If we're moving left and right, it would be normal to think that plus 1 is going to move it to the right one, when in reality what happens is it shifts everything to the left one, and we saw that by filling in the values in our table. Okay, so go ahead and see if you can apply these rules here to the you try at the bottom. Go ahead, pause the video, and when you come back, we'll go through the answers together. All right, here we go. The you try. Y equals f of x, or f of the quantity x minus 3. So we've got our f of x there, and what is this minus 3 going to do? It's going to shift everything on this function to the right 3 units. So what would be a good strategy here is to draw a couple points, like here at the vertex, a point here, a point here, a point here, and a point here on your original function, and then shift them all to the right 3 units. The minus sign, remember, inside the parentheses there, moves the graph to the right. The next problem, f of quantity x plus 2. Now this is going to move the graph to the left 2 units. So if you had your points over here, like this point right at the vertex, you'd just move it to the left 2 units to figure out where the new function is going to be. Remember, the addition here inside the parentheses moves the graph to the left. All right, let's go on here. Now, we're putting it all together, both 3.12, that's today, and the stuff from yesterday. We're going to translate this crazy-looking function to this new function. So we're going to translate f of x here all the way to negative 3 f of quantity x minus 4, and then plus 2. So what we want to do is choose key points. So if we look at what we did yesterday, we look at what we did in last section's notes, we know that we need to choose some key points. And those key points should be at turning points and at end points. So right there. And now we're going to follow PEMDAS. We're going to follow the order of our transformation. So let's start with this point over here. Let's make it blue right there. If I follow my order of operations here, the first thing is the x minus 4 in parentheses, which tells me to go right 4. So I go right 4 with that point. Now it's negative 3 times the f of whatever, the f of the function here, negative 3 times the function. So I take the output, negative 1, and multiply it by negative 3. So that makes it go all the way up to 3. Now I have a plus 2 tacked on to the end, and if I remember from yesterday, the plus 2 outside there shifts it up 2. So I've just moved this first point according to that rule. Now let's go ahead and do the same thing with the second point. So I have this point right here, it's in blue now. Follow the same order of operations. The minus 4 in parentheses means move it to the right 4 units. Then the negative 3 multiplied by the whole function here, by the f of whatever, the negative 3 means take the output. What is the output right now? It's 1, and multiply it by negative 3. So it goes down to negative 3. And then the plus 2 on the end means move up 2. So we follow the exact same set of steps here for every single point. Here, I'll go through this one real quick because it's got a kind of cool thing going on right here. So we move it to the right 4, and then we take the output value. The output value right now is 2, and we multiply it by negative 3. So we get negative 6. So we've got to go all the way down to an output of negative 6. And then finally we add 2, which shifts it up 2. So that's where that point ends up. And then finally, our last point, we follow the same set of steps that the function tells us right here, our order of operations. We apply our transformations, and we get to where the points will end up once they go through this new function. Now, in order to connect these, we look back to our original graph. So the first 2 points were connected with a straight line. We're going to need to do the same thing here. The last 3 points were in a sort of curve, a parabola, an arch, however you want to think of that. So we need to connect our new function in the same way. All right. There's a little bit more. I'm going to pause and I will be right back. All right, here we go. Here we go. Let's finish this up. So the next step here, if we have an original point on the graph, where will the point be moved to on the new graph here? So you don't have this row for old value change, old y value, the change in the new y value. So you're going to need to add that. Now, what was the old x value? We get that from the point, -3, and then the change. Think about these 3 things that are happening, the +7 in there, the multiplication by 2 out front, and the -3. Only one of those things shifts the point left and right, thus changing the x value, and that's the +7. And the +7 shifts it left, so our change is -7, and our new x value is -10. Our old y value is 4. That was our starting y value. Now, which of these things change it? Both the multiplication by 2 and then the -3. So I have to apply them in the correct order, following PEMDAS, just like we did earlier. So I multiply by 2 and then subtract 3. So 4 times 2 is 8, and then -3 gives me 5, gives me my new y value. And so this point here on f of x would get shifted all the way over to -10, 5 on this new function right here. All right, let's do one more example just like that. So original point here, function we're shifting to, we're drawing a new function right here. Old x value was 0. The only thing that changes the x value is the -5 in there, and that's going to actually shift it right 5, so +5. And so our new x value is 5. Old y value of -6. Now first I need to multiply by the 1/2 and then add the 10. So times 1/2 is -3 plus 10 gives us 7. So this point, if I shifted it and saw where it would end up on this graph, I would get 5, 7. All right, I hope you found those notes helpful and have a good rest of your day.